All right, Module 19 study guide. The first page I'm going to go through rather quickly, especially the definitions, because a lot of these definitions you have in your notes, and it's just a matter of memorizing them, especially these first two. So you should know what the standard form of a quadratic equation is, and you should know what the vertex form of a quadratic equation is before you take your test on Friday. So the standard form of a quadratic equation is y equals ax squared plus bx plus c, whereas the vertex form of a quadratic equation is y equals a times x minus h squared plus k, where h and k are your vertex. Now, when graphed, a quadratic equation creates a U-shaped curve that we call that U-shaped curve is called a parabola. So make sure you know what that U-shaped curve is called. Next, define vertex. So remember, the vertex is either going to be your minimum or your maximum. It's either going to be your lowest point or your highest point of your quadratic equation, and we'll get to that when we get to numbers 5 and 6. But for the definition part, you could just put it's the turning point of a parabola, and that's what I'll write, the turning point. The turning point of a parabola. Next, the axis of symmetry. Remember, that's that imaginary vertical line that splits your parabola into two equal parts. So that's what you would have to put for your definition. Let me pause the video and write that definition down for you. There you have it, the vertical line that divides the parabola into two equal parts. Now, let's get back to vertex. All right, so if the vertex is your lowest point of the parabola, meaning your vertex is down here, okay, then that would be called minimum. Now, if your vertex is the highest point of a parabola, meaning your vertex is on the top there, then that would be called a maximum. So make sure you know that for Friday's test. Now, all these equations, all these quadratic equations here are written in standard form, which is y equals ax squared plus bx plus c. Therefore, it's not evident what the vertex or the axis of symmetry, what both of those are. Okay, we'd have to use that axis of symmetry formula that we learned a couple weeks ago, which is x equals negative b over 2a. So make sure you know that for tomorrow's test, x equals negative b over 2a. And that's how we would find the axis of symmetry. So to find the axis of symmetry of number 7, we'd have to figure out what number's in the b position, which is 8. So that's going to be x equals negative 8 over 2 times whatever number's in the a position, which in this case is negative 2. Well, 2 times negative 2 is negative 4. Negative 8 divided by negative 4 is positive 2. So your axis of symmetry is going to be x equals positive 2. Now remember, to find your vertex, all you would need to do is plug into wherever you see an x in that original quadratic equation. So this is going to be y equals negative 2 times 2 squared plus 8 times 2 minus 5. And you'll be able to use your calculator on tomorrow's test, so you could just put that entire thing in your calculator, and you get your answer, which is 3. So your vertex would be 2, 3. Next, number 8. All right. So again, this is in standard form, so we have to use this equation, negative b over 2a. Now, what number is in the b position? It's negative 20. So that's going to be x equals negative, and then your b, which is negative 20, which is going to turn that into a positive, over 2 times whatever number's in your a position, which in this case is negative 5. Okay? Negative 20 would be positive 20, and 2 times negative 5 is negative 10. 20 divided by negative 10 is negative 2. So your axis of symmetry is going to be x equals negative 2. Now what about your vertex? Well, to find your vertex, you would need to take that axis of symmetry, that x value, and plug it into your original quadratic equation and solve for y. So if we do that, that would be y equals negative 5 times negative 2 squared minus 20 times negative 2 minus 26. All right, and you just compute that and you'll get your vertex, which in this case is going to be -2, comma, -6. And last, number 9, we have y equals -3x to the second power. So again, this is in, actually this one is in vertex form really. Remember, vertex form is y equals a times x minus h squared plus k. Okay, so this one's actually pretty simple. We could use our knowledge of vertex form to easily figure out our axis of symmetry and our vertex. So axis of symmetry is always going to be h. There is no h, so that means it's going to be 0, x equals 0. Your vertex is going to be h comma k. There is no h or k, so your vertex is going to be 0 comma 0, and we know that just because of our vertex form, or what we know about vertex form of quadratic equations. All right, now we are graphing quadratics. The first two problems are in standard form, and the last two problems are in vertex form. Okay, so for the standard form ones to graph it, you would need to first find your axis of symmetry and your vertex, and you would do that by using the axis of symmetry formula, which is -b over 2a. So in this case, b is 8, so it's going to be x equals -8 over 2 times, and then a is -2. Okay, well, 2 times -2 is -4, and -8 divided by -4 is 2. So your axis of symmetry is going to be x equals 2. We're going to use that axis of symmetry to figure out our vertex. All we would need to do is plug in 2, and you will receive an x. So for our vertex, it's going to be y equals -2 times 2 squared plus 8 times 2. Well, 2 squared is 4, and 4 times -2 is -8, and then that's plus 16, so your vertex is going to be 2 comma 8. That will be your vertex. So then remember, we put the vertex in the middle row of our table, 2, 8, and then we just fill out the rest of the table, 1, 0, 3, 4, and you plug all of those values into your calculator, and if you do that, you would get 0, 6, 6, and 0, and then just graph it. Well, 2, 8 is going to be all the way up here. 1, 6 is going to be over here. 3, 6 is going to be over here. 0, 0 will be down here. 4, 0 will be down here. And you draw your parabola. Just like that. All right, now it's going down, and that should make sense because our a was negative. Remember, if a is negative, the parabola will be pointing or be opening downward, which means the vertex would be a maximum. Now your domain in this case is always going to be all reals, and then a range, remember, it's going to be y is either less than or equal to or greater than or equal to, depending on which way the parabola is opening, and then it'll be the y value of your vertex. Well, the parabola is opening downward, so it's going to be less than or equal to, and then the y value of our vertex is 8. And hopefully that makes sense, because if you look at 8, if you look at y equals 8, the graph is all going downhill from there towards negative infinity, and that's why your range is y is less than or equal to 8. All right, and there are no values above 8 if you look at y equals 8. All right, so next one is also in standard form, so we'll have to use the axis of symmetry formula, which is x equals -b over 2a. Okay, so in this case, the number in the b position is -2, so it's going to be x equals -2 over 2 times, and then in the a position we have 1. So -2 is 2, and 2 times 1 is 2, so our axis of symmetry is going to be x equals 1. Now to find our vertex, we would just plug in that axis of symmetry. So I'll do the vertex down here. To find the vertex, it would be y equals 1 squared minus 2 times 1. Well, 1 squared is 1, and 1 minus 2 is -1. So our vertex is going to be 1 comma -1. Okay, now we're going to put that value in the middle of our table. and then fill in the rest. And you put all that in your calculator, or this one's easy enough where you might be able to just do it in your head. So if you plug in -3, you get 3, 0, 0, 2, 0, and then 3, we get 3 again. All right, and then you just go ahead and graph it. So -1, 3 is right here, 0, 0 down here, 1, -1 down here, 2, 0 over here, and 3, 3 is right here. And this parabola is opening up because our a was positive. Okay, domain is going to be all reals. Your range is going to be y is greater than or equal to, because it's opening up. Then the y value of our vertex is -1. So y is greater than or equal to -1. Now let's get to the easier ones, because these are in vertex form. Vertex form, you need to remember, is y equals a times x minus h squared plus k. So if we have a quadratic equation in vertex form, then that would just mean that our vertex is going to be h comma k. Remember, h is opposite. These h's are opposite. So the number in the h position appears to be 5, but because h is going to be opposite, our vertex is actually going to be -5, comma, and then what number's in the k position? Nothing, 0. So it would be -5, 0. And then remember to find the axis of symmetry. The axis of symmetry is just going to be x equals h, and h was -5. So your axis of symmetry is going to be x equals -5, and your vertex is going to be -5, 0. Your domain is going to be all reals, and we would just fill that table up and down and plug all those values in to figure out how to graph this. All right, so if you plug in -7, you get 4. If you plug in -6, you get 1. And at -4, we'll also get 1, and at -3, we'll get 4. All right, and then you just graph it. -7, 4 is right here. -6, 1 is right here. -5, 0 is right here. -4, 1 is right here, and -3, 4 is right here. Then we draw our parabola, just like that, and there you have it. Your range is going to be y is greater than or equal to, because it's opening up, and then whatever the y value is of our vertex, which in this case is 0. Oh, and in this case, we also need to talk about transformations, which I'm going to talk about in more detail during on the last page of this study guide. But this is +5. We're changing our h. Our h is well, our h is actually -5, because remember, h is opposite. So remember, h, when we're talking about transformations, h is what controls the horizontal shift. So because h is -5, that means we are going to the left 5 spaces, and this is in regards to our parent function, which is y equals x squared. Okay, so we're going to the left 5 spaces. Now, this one, also in vertex form. Remember, your vertex is h comma k. Number in the h position is 2, because remember, h is opposite. And the number in the k position is -6. So that's 2, -6. Your axis of symmetry is going to be x equals h, which in this case it would be 2. X equals 2. So we could already fill that part out. Axis of symmetry is x equals 2, and your vertex is 2, comma, -6. All right. Then we would just fill out this table. So I'm going to put 1 here, 0 here, and I'm going to put 3 here and 4 here, and we'll just compute this. So at 0, we'd be at -2. At 1, we'd be at -5. At 3, we'd be at -5, and at 4, we'd be at -2. Okay. Then we would go ahead and plot this on our coordinate plane. So 0, -2 is right here. 1, -5 is right here. 2, -6 is right here. Then 3, -5 is right here. 4, -2 is right here. Okay. Go ahead and draw our parabola, just like that. And your domain is going to be all reals. It's opening up, so it's going to be y is greater than or equal to, and then whatever the y value is of your vertex, which in this case is -6. Let's talk about transformation. So our h was +2. Remember, h controls a horizontal shift, so that means we are going to the right 2. in relations to our parent function, which is y equals x squared. So we're going to the right 2, but we are also, this minus 6 in the k position is going to make us shift downward 6 spaces. So we're going down 6. That's what you would write under transformations. All right, remember, h controls the horizontal shift. Let me write the vertex form again so that you can visualize what I'm saying here. H controls the horizontal shift, K controls the vertical shift, and then A would either make the graph wider or more narrow. And if A is negative, it will also flip the graph. All right, or reflect the graph along the x-axis. All right, so if we look at number 14, it looks like we have a change on the horizontal. What does h equal? Remember, h is always opposite, so h is going to be 2. And that tells us that we are going to the right 2 spaces. What does k equal? K is -1. That tells us we are going down 1 space. And those would be the only 2 transformations for this equation in relation to the parent function, which the parent function is, I should have written that here, y equals x squared. Next, number 15. If we look at this, no change in the horizontal, no change in the h, but we do have a 4 here, which is going to make the graph more narrow. So if this is the parent function, that 4 is going to make the graph more narrow like that. Okay? So the 4 would make it narrow. Okay, and then we have a -5 in the k position. K is -5. Actually, I should have probably written it this way. Let me write it this way. A is 4, which is a number that's greater than 1. So because of that, we're going to have a more narrow graph. And then k is -5, which k controls the vertical shift. That means we're going down 5. All right, quite a few shifts here. I'm sorry, quite a few transformations here. First, we have this negative. So the negative is going to cause a reflection or a flip. So what that means is if this is our parent function and we have a -a, then it'll flip over along the, or reflect along the x-axis. Okay. Then we have a 1/2 in the a position. So a is 1/2, which that would cause it to be wider. Meaning if this is your parent function and we have a fraction less than 1 as our a, it's going to make it wide. That's horrible, but it's going to make it wider. Sorry about that. That's better. It's going to make it wider. The parabola is going to become wider. Okay. And then we also have an h, which is -1. Remember, h is opposite, so if this is +1, that means h is -1. And that's going to cause a horizontal shift, which is going to make it go to the left 1 unit, or 1 space. All right, transformations from the parent function are given below. Write an equation to represent the function. All right, reflected over the x-axis, so that tells me that a is going to be negative. Then translated 6 units left. Okay, so it's going to be y equals x squared. That's our parent function. Now let's talk about the new equation that is represented by these transformations. So first of all, we have a reflection. So that means we're going to have y equals, and we know we're going to have a negative. The negative is what's going to cause a reflection along the x-axis. Then we have a change in the horizontal, which is controlled by the h value. So that would mean it's going to be x. And because we're going to the left, remember h is opposite. So because we're going to the left, that means it's going to be plus. Now how many units are we moving to the left? 6. And that's squared. All right, now number 18. Vertically stretched, or more narrow, by a factor of 5/2, and then reflected over the x-axis, then translated 3 units down. Okay, so again, our parent function is y equals x squared. Okay, we have a reflection, so that right there tells me it's going to be negative. That's how we get it to flip over the x-axis. Now, a vertical stretch, that means making it more narrow, which means that we are going to change our a. Our a is going to become 5/2, which is a number that's greater than 1, which is why it's making the parabola more narrow. Okay, then we have Actually, we don't need the parentheses this time because we don't have a change in h, right? Our change is in k. Our change is in k. We're going 3 units down, so that would mean minus 3. We have no change in h, so we don't need the parentheses. All right. What is the parent function of a quadratic equation? Y equals x squared. You need to know that y equals x squared is the parent function. You're going to have a specific question asking you for the parent function of a quadratic equation. You should also know the parent function of a linear equation, which is y equals x, parent function of an absolute value, which is y equals the absolute value of x. All of those should be in your mind, especially as we get closer and closer to our end of year exam. All right. That is it for your study guide. Make sure you study all of these, especially the vocabulary terms and the definitions we went over on the first page of the study guide. Your test will be on Friday. I am sure you'll do well so long as you study. If you need any extra help, come and see me during tutoring. All right, have an awesome day. See you tomorrow.